In this video, we'll be talking some more about trig functions of non-acute angles. Our first example is to evaluate the sine of 585. Since this angle is more than 360, let's find its coterminal angle by subtracting one revolution. So 225. Now for our reference angle, 225 is more than 180 and less than 270, so it'll be a terminal side in quadrant 3. So to find our reference angle, we need to take our angle, 225, and subtract 180. So that gives us a reference angle of 45 degrees. So if we mark that here, and then draw our reference triangle, we see that it is a 45, 45, 90 triangle. So we can put in our 1, 1, root 2. And this side, the x coordinate will be negative because it's left. And the y coordinate will be negative because it's down. So our sine then of this angle is opposite over hypotenuse, which is -1 over root 2. And then last thing, we need to rationalize this denominator. So multiply top and bottom by that radical. And we have a negative radical 2 divided by 2. Let's do another one. Again, we need to find the coterminal angle. This one's negative, so I'm going to add revolutions. So a negative 930 plus 360 is a negative 570. And then if we add another, that is a negative 210. And we could go with that, or we could add another revolution and get our positive coterminal angle, be 150. So our drawing, 150 is more than 90 and less than 180, so the terminal side of that angle is in quadrant 2. This is our 150. So to find our reference angle, we want to take 180 minus 150. And we have 30. So we can now draw our reference triangle. We know that we have a 30, 60, 90 triangle. So for convenience, I'm going to let my hypotenuse be 2. Then the side opposite the 30 is half of that, which is 1. And the side opposite the 60, and there's my 60, will be half the hypotenuse times the square root of 3. So 1 square root of 3. Since our point here is in quadrant 2, left is negative and up is positive, so the x coordinate is negative. Alright, now we're asked to find the cotangent of this angle. Well, tangent is opposite over adjacent, so that would be 1 over negative root 3, but the cotangent is the reciprocal of that. So I need to flip that ratio, and I'll have a negative root 3 over 1, which simplifies to negative root 3. Our next problem is to find all values of theta if theta is in the interval from 0 to 360, including the 0 boundary but not the 360 boundary. And we're also told that the sine of theta is negative root 3 over 2. Alright, this is there only to keep you from doing more than one revolution. So we're just talking about the 4 quadrants, nothing more than that. And then also no negatives, since my interval does not include any negative numbers. Alright, then also sine is negative. Well, if we do our all students take calculus, sine is positive here, because all of the ratios are positive in quadrant 1. And students, S, sine is also positive in quadrant 2. So I'm told that my sine ratio is negative, which means that my angle is either in quadrant 3 or quadrant 4. Now let's draw our reference triangle here. Sine is defined as opposite over hypotenuse, or y over r. So that means our opposite side is going to be a negative root 3, and our r value is 2, since r will never be negative. And the same way on this reference triangle, my opposite side is a negative root 3, and my r value is 2. And the problem was to know what is the theta, all values of theta. Well, we should recognize this as a 30, 60, 90 triangle because of that r value of 2 and the side value of root 3. This side will be a 1, actually negative 1. And the angle that's opposite the root 3 is our 60-degree angle. So our reference angle is 60. And same way on this one, our reference angle would be 60. So to answer the question on this problem, I need to find the angle that has a reference angle of 60 there, and then also here. Well, for the smaller one here, I can see that if I just take 180, that goes to here, and then add my 60 on. So 180 plus 60 will give me 240. And then for the big one, I would do a complete 360 and then back it off. A complete 360 and then back it off 60. And then that would give me 300 degrees. So we're asked to find all values of theta in the interval from 0 to 360, including the 0 but not 360, that have a secant of negative root 2. So if we look at our sketch, secant is the reciprocal of cosine, and so we know that cosine is negative in the left 2 quadrants. So our secant will also be negative in our left two quadrants. So let's go ahead and draw our reference triangle. Now secant is defined as hypotenuse over adjacent. So my adjacent side will be 1, and my hypotenuse will be a root 2. Now it won't be a negative root 2 because this r value is always positive. So I need to stick my negative sign on the adjacent side. The same way here. Now whenever we have a hypotenuse of radical 2, that means that we're dealing with a 45, 45, 90 reference triangle. So for our theta value, we need to take 180 minus 45 to get this value, and that'll be 135. And then we need to take 180 and plus 45, and that'll give me this one in quadrant 3. It's 225.